COEPP is the ARC, the Australian Research Council Centre of Excellence for Particle Physics at the terascale.
It's the primary centre in Australia for looking at particles at what's considered the energy frontier.
It's been funded to analyse the data of the Large Hadron Collider using the ATLAS experiment.
It brings together theoretical and experimental physicists, as well as computer scientists and system administrators.
And there are 4 universities involved. University of Melbourne is a lead agent for COEPP, also University of Sydney, Monash University and University of Adelaide. So it's interesting to reflect on the involvement of Australia in the discovery of the Higgs boson. So firstly, we had a number of people in the ATLAS experiment whose names appeared on the paper. University of Adelaide, University of Melbourne, University of Sydney, all their names are on the Higgs discovery paper.
And we were lucky because at that time there was the biggest conference in particle physics, and it was in Melbourne. So the announcement of the Higgs boson was done together at CERN and in Melbourne.
Many of the collaboration knew that we had discovered this particle, and we were under oath of secrecy to not let the cat out of the bag.
About 1,000 people from all over the world came down to Melbourne, so even we did not know that. It was a little bit like the night before Christmas, when you knew that something big is going to happen next morning, but you never actually knew what your present was.
It was a very exciting time for everybody because we'd put so much effort into it, not just in the building of the experiment, which took a long time, but we have staff members here at Melbourne and elsewhere, and students who'd worked on the extraction of the signal, which was a very major task.
My research is mostly focused on the physics of the top quark, which is one of the fundamental particles. And I look at measurements of how often it's produced in comparison to other particles in the collisions that we see at the LHC. It's always going to be difficult to collaborate with people who are in very different time zones. So when you have people, mostly in Europe, the time zones of all our meetings and stuff are very skewed towards Europe, which is not so fortunate for people in Australia. And it often means that we have meetings at 2 a.m, 3 a.m, these sorts of things. So when I showed up to CERN on the first day, I needed to register so that I could get my ID card. And the process of registering involved going to several different buildings, which are all named by their number. They're all just numbered buildings. And it's a huge complex, and the numbers don't seem to be arranged very logically. So it was a very confusing time trying to find all the right buildings. So I was given a map to help me find all the places, and yeah, that helped a lot on the first day. So the typical day while I was at CERN involved getting into the office pretty early in the morning, catching the bus from the town in France where our apartment is. And once we get to the office, I shared an office with 2 people who were working on research computing. And I would respond to emails because there's an overwhelming number of emails in the collaboration of the size. And then largely work for myself at the desk. So, although physicists are pretty renowned for drinking coffee, most of the coffee at CERN is in the form of vending machines. So most people get their coffee from the main restaurant there. And you need to buy these tokens from a machine that lets you get to the coffee. Well, now that the Higgs boson is discovered, it's incorporated into all the analyses that are done at the ATLAS, so where it's relevant, it's a background to the signals that we're looking for and all that. But the excitement of it has sort of faded a little bit, and there's people are focused on the next big things that are going to happen.
Doesn't mean that we finish. We are still a lot of physics we don't understand. For example, the Higgs boson explained the mass of the particle we know, but 85% of the matter in the universe is of a nature that we don't know, and we call it dark matter.
It's amazing to work on an experiment that's so big because it really has the potential to address the big questions, the big fundamental questions of particle physics and science at the fundamental scale.
We're trying to study the environment of the Big Bang. What better job could a person have?